So here we have question number 16. Again, it's still subtract. So what we're going to have to do anytime that you're subtracting any type of fractions or rational expressions is you gotta see if these match or no match. The only way you can do any addition or subtraction, they have to match the same size. Right now they're not. This is 4x minus 8, which is different from x minus 2. So if they're not matching, we need to find the LCD. That's our second step. We told you to find the LCD, you have to factor out each of the different denominators. This is two terms. Do not do tree diagram. Go into GCF. 4, 8. You know you have a GCF for numbers. We don't have it for letters because this doesn't have a letter. We don't have it for signs because this doesn't start with a negative. And of course we don't have matching parentheses. So the only thing that we can take out is just a common number. So when you divide both by 4, your leftovers are going to be x minus 2. Now let's look at this denominator to see if we can factor this out. I know I can't factor this out any further because when it's two terms, difference of squares, that's not a perfect square. So when I come to this corner, do I have a GCF? No. Two terms, remember, no tree diagrams. Two terms, you have to say, can I do difference of squares? Minus sign, yes, but 2 is not a perfect square. Since this cannot factor out, put it in parentheses so that you know this 2 is connected with the x. Then create your LCD list. Do you have a 4? No, there's nothing in the list, so put in a 4. And if you want to put a comma, you can. If you don't, it's up to you. The next factor, x minus 2, that's a new factor. X minus 2 is already in the list. So there's only two different types of factors these denominators have, 4s and x minus 2s. Let's raise each of the fractions. But if you notice, for the first fraction, don't use this original, use the factored form. Because if you use the factored form and you compare it to the LCD, you can see nothing's missing. 4, 4, x minus 2, x minus 2. Since there's no extra pieces, you can bring this over. You're not really transforming it. Take the other fraction, x minus 3, over x minus 2, and then you can clearly see we are having an extra piece. See how it was originally x minus 2, the factored form? And then our LCD is 4 and x minus 2. So you can see the extra piece is 4. To get the new top, you have to take the old numerator times it by the box. When you distribute, you're going to get 4x minus 12. So instead of using the originals, let's use the equivalents. So because I have a tight board, I always want to erase these originals because we're not going to deal with them no more. We're going to deal with these raised guys, the way it looks. 5x minus 14 over that LCD, 4x minus 2. And then this guy, 4x minus 12 over 4 parentheses x minus 2. Once we have that, and we have the raised fractions, then we told you, look at the problem again. Do they match or no match? They match now. 4, 4, x minus 2, x minus 2. So now that we found the LCD, we did our raising, we got them to match. Remember, step 5 is just keep the same denominator. Notice you have two denominators, it becomes 1. Over the semesters, I've noticed people would write this down twice at the bottom. Two denominators just become one denominator, write it only once. Then, let's fix the numerators. This is where I really want you to use parentheses. The reason why is because 1 is subtraction, and 2 is because we're dealing with binomials. That's really key that you want to work with parentheses. So put this numerator in parentheses to separate this numerator in parentheses. So we'll write this first. Then we're going to write the subtraction sign. And then we're going to write this numerator with the parentheses. Notice it's all now on one fraction bar instead of two separate fraction bars. To get rid of these parentheses, we will distribute understood 1. So 1 times 5x, and you're going like, well, that didn't change. 1 times negative 14, that didn't change. But when you distribute this negative 1 out, negative 1 times 4x is negative 4x. Negative 1 times negative 12 is positive 12. See how you would not have gotten the positive 12 if you didn't use parentheses and distribute that negative 1 out. Once we got rid of the parentheses on top, just collecting like terms, you can see that we have variable terms with variable terms, constant terms with constant terms. You know how to collect. Remember, if one's a positive and one's a negative, you always subtract and then see who wins the tug of war, 5 players versus 4. So we know we're going to get 1x, and 1x is the same thing as x. Remember, there's an understood 1 here, so you don't have to write it in. And then the negative 14 and positive 12, different signs, so subtract again. 14 players versus 12 players. Team 14 wins the tug of war, so you're going to have a negative 2. Remember, the bottom just stays. Once we finish collecting the like terms, then we told you step 7, can this reduce? And you look, can you factor out the top? Remember, the top is a binomial because you got this minus sign here. So make sure you realize this is a binomial. Do we have a GCF? No. Do we have difference of squares? No, not a perfect square. So the top cannot factor out. So put it in parentheses so you can see it's a binomial, and then you realize, wait a minute, I have an x minus 2 on top and x minus 2 at the bottom. They cancel out. So our final answer is going to be 4 at the bottom, and since there's nothing left on top, there's always understood 1, which you have to write in. Anytime there's nothing left on top, you have to write the 1 in. If there's nothing left at the bottom, you don't have to write the 1 in, but on top, you do. So that's how we get our answer of not 4, but 1/4, since there was nothing left on top.